Good evening. I'm going to try and make this a quick video just to kind of refresh your memory about how to find the x-intercepts and graph them. So for number one, we learned today that we can graph this quadratic equation by finding the x-intercepts, and then when we find the x-intercepts, then we can plot that with the axis of symmetry. I'm getting ahead of myself. Let me do it first by factoring to find the x-intercepts. 3 here, 4 here, and 3 and 1 here solves it. The factors are x plus 3 and x plus 1. I'm taking the factors right from the diamond because this leading coefficient is 1, so I'm taking a shortcut. So our x-intercepts are x equals -3 and x equals -1. It's the point of the graph where the parabola crosses the x-axis, where it equals 0. X equals -3 and x equals -1 are the x-intercepts. And then very quickly we can see that the axis of symmetry is in between those two x-intercepts. So the axis of symmetry is at x equals -2. Now to find the vertex, I plug that value in to the function to see what value I get out of the function. X equals -2 is -2 squared plus 4 times -2 plus 3. That's 4 minus 8 plus 3, and that's -1. So the vertex is at -2, -1. Now this graph is going to be opening upward because a is greater than 0. So this is exactly what I would expect, is to see this vertex down here somewhere. Now the y-intercept, remember, is this value here. So 1, 2, 3. And I can reflect that across the axis of symmetry. And there's 5 points needed to make a nice smooth curve for the parabola, and it's graphed. So number 2 follows the same exact pattern. Number 3, to factor this, remember, factor out the GCF. So the x-intercepts are x equals 0 and x equals 2. Now when you graph this, you'll find that because c is equal to 0 here, that you already have a y-intercept used, so you're going to have to plot additional points. But make sure you get 5 points to graph that. For number 4, remember that when you factor this, you can use the square root method and take the square root of x squared, so that's x. And the square root of 1 is 1, so that's plus or minus. Or you could use your diamond and let b equal 0. And then you graph, but here your x-intercepts are x equals -1 and 1. Interestingly, when you graph this, the axis of symmetry turns out to be the x-axis. So here's my x-intercepts, but the line between them is the x-axis. So you can maybe dot a little bit above and a little bit below, but that's the axis of symmetry. So the AOS, x equals 0. This is where x equals 0. It's not 1 or 2 or -1 or -2, it's 0. This is where x equals 0. So I'll put 0 into the function to get my vertex, and I get 0 squared minus 1, so that's -1. So the vertex is 0, -1. So there's the vertex. And as I was saying earlier, sometimes we have to plot additional points because our y-intercept is -1, so that's already plotted. So the y-intercept is -1, the c value, and so we'll have to plot, maybe put 2 into the function. So if x equals 2, we get 4 minus 1, that's 3. So the point is 2, 3. That's the additional point. 1, 2, and then up 3. And mirroring that point across this axis of symmetry, which is here, 1, 2, 3, 4, and then draw a curve. Number 5 and number 6 are not factorable. So in order to graph number 5 and number 6, you have to fall back to what I like to call the axis of symmetry method, AOS, where x equals the opposite of b over 2 times a. Now this parabola has a negative value in front of the x squared, so I would expect this parabola to open downward, and it will. It will open downward. So what is the axis of symmetry? Well, it's going to be the opposite of b, so that's negative 2 over 2 times negative 1. So that's negative 2 over negative 2, which becomes 1. So the axis of symmetry is x equals 1. For the vertex, I'll put x equals 1 into the function. Negative 1 squared plus 2 times 1 plus 2. And I get negative 1 plus 2 plus 2. That's negative 1 plus 2 is 1 plus 2 is 3. The vertex is 1, 3. Oh, I better start putting these on my graph. The axis of symmetry is at x equals 1. Right there. The vertex is at 1, 3. The y-intercept, remember, is c, so that's 2. I can reflect that across the axis of symmetry. I will need to find an additional point. So 1, 2, 3, I'll use x equals 3. When I put 3 into the function, I get the opposite of 3 squared plus 2 times 3 plus 2. It's the opposite of 9 plus 6 plus 2. That's negative 3 plus 2. That's equal to negative 1. So when x is equal to 3, the y value is negative 1. 1, 2, 3, negative 1. And then I'll mirror that 1, 2, and 1, 2. And there's my parabola. And it's graphed. So on number 6, you'll need to do the same thing. You'll need to find your AOS by using x equals the opposite of b over 2a, then your vertex, your y-intercept, and any additional points. Then do your curve.